Hi, we're going to talk about when to use the median versus the mean. Why use the median? Why use the mean? I mean, we know they're both measures of central tendency, and usually in class, someone will just tell you, please calculate the median. But in most situations, you won't be afforded the luxury of somebody just cueing you which one you should use. So first, let's start with why use the median. The nice thing about the median is that it's not going to be overly affected by situations like this, where here's this large clump of data and here's this little outlier out here that really shouldn't matter very much. And the median is going to help with that because the median is not very affected by outliers. To demonstrate, here's the median, kind of in the middle of this larger clump of data without the outlier, kind of where you would expect it to be. But it turns out the median, even when you include the outlier, is roughly in that same place, right? So that's the nice thing about the median, not overly affected by this outlier. The mean, on the other hand, that's a different situation. So the mean, without the outlier, is in that same place, in that center of the clump of data, just like the median was. But when the mean includes the outlier, it's overly pulled in the direction of that outlier, right? And you know, that's a little bit, that's small, but still it's too influenced by that outlier. And so the mean, it's not so great to use in these kind of situations where you don't want to, you don't want to be overly influenced by these outliers. So we know this about the mean. We know that it's susceptible to outliers. Yet, in your statistics class, you will see the mean all over the place. You will hardly talk about the median, right? So why use the mean? That's the question we want to focus on today. In order to talk about that, it helps to have a little set of data that we could talk about, makes things a little more concrete. So here's a set of data, 5, 5, 5, 10, and 20, right? A little set of data. If you wanted to find the median, it's pretty straightforward. You line all the numbers up, you look at the middle number, right? So you have an equal number of values above the median, 2 over here, and you have an equal number of values below the median, 2 over here. The median is right in the middle. And the median largely doesn't care whether that 20 out there is a 20 or a 2 million, right? The median's still going to be 5, not affected by outliers. In order to talk about why the mean is useful, it actually helps to represent that same data in a different way, in a way that actually where you could see the values or the extent of those data points. So here we've put the values on a dot plot or a number line. And you could see that, hey, here's the 5, 5, 5, 10, and 20, same data set as before. But when you calculate the mean using that nice formula, 5, 5, 5, 15 plus 30, so that's 45 divided by 5 data points. The mean is 9, right? Notice that 9 is not 5, right? It's not the same thing. It's not the same number as the median, right? Well, why is the mean 9? I mean, yeah, I know that's the right calculation of the formula, right? But what makes 9 the middle number? Why not 8 or 9.5, right? Any of these numbers in the middle could be the middle, right? Why is 9 so special? Well, in order to answer that question, it helps to have a metaphor in mind. And you may have heard this metaphor before, that the mean is the balancing point of a distribution of data. What does that mean? What is it balancing, right? Well, you might think, maybe it balances the actual values below the mean and above the mean, right? So let's try that. Well, here you could see the numbers below the mean, they add up to 15, and the numbers above the mean add up to 30. 15, 30, they don't balance, right? And unfortunately, that's going to be the case in every single distribution because small numbers, when you add them together, are going to be smaller than large numbers when you add them together, right? Okay, so the mean does not balance the values. What does it balance? In order to answer that question, you're going to have to think about the distances between the mean and the data points, right? These are called deviations. These distances are really important to statistics. And when you look at these distances, you're going to start to answer that question of what does the mean balance. So when we put numbers here, you could see the distance or deviations between 9 and 5 is 4. So 4, 4, and 4. And the distance between 9 and 10 is 1. And the distance between 9 and 20 is 11. right? Do those deviations add up, right? Do they balance out? That's where we start to see the answer. So here, when you add up these deviations that are smaller than the mean, you get 12. And when you add up the deviations that are larger than the mean, you also get 12. That's the answer. The deviations balance out. That's why the mean is considered the middle. And if you think about it, that's kind of cool that that formula for the mean, add up all the data points, divide by n, that formula leads to this number that perfectly balances the deviations, both smaller than the mean and larger than the mean. Now, this idea of deviations is actually really important in all of statistics, okay? Not just the mean. And here's why. We want you to actually think about those data points, those white dots that I showed you before, as composed of two components, the mean and these deviations from the mean, right? So if you think about it, each data point is like mean plus a little bit of jiggle, plus a little bit of error, right? And that's how we want you to start thinking about data, not just as those white dots. And because of that, we're going to start to use this kind of notation, where that sample data is really composed of two components, the mean and the error off the mean, how off that error is from that real data point, right? And so when you think about the data, the sample data in this way, it's going to give you a whole new way of thinking about statistics, because statistics is going to be all about trying to reduce this kind of error, being able to explain in a way that reduces that error. Now, it seems like overkill to do this with the mean, because it is. We don't usually do this with the mean. But the reason why I want to point that out is because in statistics, we're going to be in the business of trying to model data. And a good model is going to reduce the amount of error off the model, right? And so here, we're using the mean because it's a really simple model that you could really clearly see at the beginning of a statistics class. And you could kind of see how the data is composed of the model plus the error around the model. And another reason why the mean is kind of an important first model to look at is that it's what we call an unbiased model. This is a case where the errors on this side, on the smaller than side of the mean, is perfectly balanced by the errors on the larger than side of the mean, right? And so the mean is pulled equally in both directions. Because if you really think about it, the sample data is 5, 5, 5, 10, and 20. 9 is a pretty horrible representation of that data. It's totally wrong. It's never right. But it's unbiased in that it's not too swayed by the smaller numbers. It's not too swayed by the larger numbers. It's right in the middle, such that all the numbers get to have a say, and it's perfectly balanced on both sides. It's equally wrong in the small direction as it is on the larger direction. So, going back to our question, median versus mean, why use the mean? Two things I want you to remember. One goes back to the idea of the values. If all the values are important, the actual extent of those numbers matter, then you want to use a measure of central tendency like the mean. It's going to take the values into account, and it's going to take every data point into consideration. But also, if you need an unbiased estimator or an unbiased model of your data, you want to use something like the mean, because the mean is going to be equally wrong in the smaller than direction as it is on the larger than direction. The deviations on both sides are going to balance out.